Hey everybody, and welcome to another lecture with Coding with Roby. And in this lecture, we're going to be going over basic SQL queries. All right, let's start by going over inserting data into a database table. Imagine our to-do database table. A single to-do record within our database looks very similar to this. Our to-do will contain an ID, which is our primary key to identify each record, a title for the title of our to-do, a description that describes the to-do and gives it a little bit more information, priority, which is the ranking of how important it is to accomplish this to-do, and a complete column, which displays if the to-do is complete or not. And eventually we'll be adding a foreign key of owner, which connects this to-do to a specific individual or user. So in SQL terms, how do we add data to a to-do? To start, we need to say which fields of the record we want to add to. We can see the SQL command that says insert into to-dos, so insert into the to-dos table a title, a description, priority, and complete. We can see we are not saying ID, and that's because we want the database to handle this automatically for us and to auto increment so we can't accidentally assign the same primary key to two different to-do records. We then want to type values, which is go to store, to pick up eggs, for as a priority, and false for complete. When we run this, we will be able to see that we are creating a new record in the database. Our title, description, priority, and complete all get updated based on this command, and we now have our database configured to auto-increment the ID on its own. This way we never have to worry about updating the ID ourselves, and we can trust the database to do this for us. Alright, now that we've created one record in our database, let's create another record. We'll be inserting into our to-dos a title, description, priority, and complete. And we'll say the values of these are haircut, need to get length of 1 millimeter, 3 priority, and false for complete. Once we submit this to the database, we can see that we now have two records in our database, one with an ID of 1 and one with an ID of 2. Alright, now that we just went over inserting into our database, let's keep adding to it. Now, I'm just going to pretend we are inserting this data, so let's move on to a new record where we just created a feed the dog as a title. As a description, we are going to be using make sure to use the new food brand with a priority of 5 because we need to feed our dog and not complete. And then let's add another one about watering our plant as a title. Description is inside and outside plants with a priority of 4 and also not complete. Let's add a fifth record of learn something new, learn to program, 5 and also not complete. And lastly, let's pretend we added a sixth record, which the title is shower. And the description is you have not showered in a few days, so it's probably a good idea to take a shower. A priority of 5 because you smell really bad, and complete is false. All right, well, we now have some data in our database. We now want to be able to withdraw data from our database. So how can we do that? To be able to start, we need to use the select attribute. We can say select asterisk from to-dos. Now in SQL, an asterisk means all columns and rows. So with this example, we are saying select all rows and all columns from our to-dos table, which in reality would just give us everything in that table. So all 6 records we currently have saved in our database will be displayed on the screen. What if we modified our select script just a little bit to only retrieve the titles of our records? We can accomplish this by saying select title from to-dos. By doing this, we are selecting just the title from our to-dos columns. Our response from the database will look very similar to this. we get go to the store, haircut, feed dog, water plant, learn something new, and to shower, with no other information. And that is because we are specifically said we only want the titles from the table to-dos. What if we modified our select script even a little bit more to retrieve the description of all the records? Well, this will be very similar to how we handled the title portion of our select command. We can accomplish this by saying select description from to-dos. By doing this, we are selecting just the description from all the to-do columns. Our response from the database would look very similar to this. We will get to pick up eggs, need to get length 1 millimeter, make sure to use new food brand, inside and outside plants, learn to program, and you have not showered in a few days. Well, being able to get only one column may be great in theory, but in our case, it doesn't actually do much. If we get a title, we want the description as well, and vice versa. Let's go ahead and modify our SQL command a little bit. Now let's type select title, comma, description from to-dos. This will properly select all titles and descriptions from our table, which will give us the titles and descriptions that we are seeking. And there it is, great job. We get the title and description from our to-dos table. Let's keep this going and add another column to our select command. This time we are going to be adding priority along with our title and description. We can accomplish this by saying select title, description, priority from to-dos. This will retrieve all titles, descriptions, and priorities from our columns. And now we will be able to see our titles, descriptions, and how important each task is. Now that we covered the select command from SQL, let's keep this learning up and learn about the where clause. The where clause specifies criteria that a field value must meet for the records that contains the values to be included in the query results. Let's check this out. Okay, remember when we wrote select asterisk from to-dos and we returned all rows and columns from the table to-dos? This time, we will be writing the same thing. However, we'll be adding a where clause where the priority of the record must be equal to 5. This means we are selecting all rows and columns where a priority is equal to 5. Therefore, when we run the SQL statement, we will get only 3 of our 6 records returned. This is because only 3 of the records have a priority of 5. But we'll be getting all columns of each of these records. Let's try another SQL statement with a where clause. This time, let's write select all from to-dos where title is equal to feed dog. So this means we are saying let's select all rows and columns where title is equal to feed dog. Well, based on our table, we only have one record where title is equal to feed dog. Therefore, if we run this execution, and we will get only one record back, which is feed dog as the title. Okay, now the main use case for using the where clause is when trying to identify a record by ID. We can pretend that our API passed an ID and we want to return that specific ID and record. Well, if we are in the database, we can say select from to-dos where ID is equal to 2. And to put this in plain English, this is saying select all rows and columns where ID is equal to 2. And this time when we run the script, we will get our single to-do record, which has an ID, our primary key, that is equal to 2. Let's now move into the update clause. The update clause is used when we want to update a record in the database. Now to update a record, we will have to use a few different attributes. We will have to say update to-dos set complete equal to true, where ID is equal to 5. So in theory, this is saying update all rows and columns to now have complete be equal to true, where a record has an ID that is equal to 5. Therefore, the record with the ID of 5 will change the complete column to true. This can be kind of confusing at first, but the more you work with it, the more sense it starts to become. We are saying we are making an update to the to-dos table, and then setting a column field to a new value, and then just locating the record we want to update to make the update true. Now in the last slide, we used an ID to identify which record to update. This is by far the most practical and best way to update a record, is to always locate the record by the primary key, because the primary key is going to be unique. However, it is possible to push an update when not talking about the ID. For example, we could say update to-dos set complete to equal to true, where title is equal to learn something new. This will essentially update all rows and columns to now have complete equal to true, where title is equal to learn something new. This will work and modify the record where the title is learn something new. However, the issue with this approach is that there could be more than one title that says learn something new, and that means nothing is unique. So if you want to use this approach, always remember that, the title is not a unique name. Therefore, we could be changing multiple records to true. All right, and now for the final clause for this basic SQL intro is the delete clause. This clause is used to delete a record from a database. Again, the best way of deleting a single record is by the primary key, which in this case is the ID. We can say delete from to-dos, where ID is equal to 5. This statement says to delete all rows and columns, where ID is equal to 5. Therefore, after this statement gets executed, we will be left with a table of 5 records. However, the record with the ID of 5 is completely deleted. Now, in many applications, if you do not want to completely remove a to-do, so a user has a history of to-dos, the application will create a table that holds quote-unquote deleted records. This way, things are not permanently erased, but just removed from the table of the main application, and moved to another table where the table still exists. And as always, you do not have to delete based on ID or a primary key, even though it is significantly more safe. We could write delete from to-dos where complete is equal to 0. This will delete all rows and columns where complete is equal to 0. So if we did not change any of our complete areas to true, we would essentially erase and delete our entire database. This is the risk in using the delete functionality when not using it by a primary key to delete a specific record. Alright, now I know we went over a bunch of SQL commands and the most popular commands when dealing with CRUD operations in case you want to manipulate the data yourself. Luckily for us, SQL Alchemy handles a lot of these commands on the application side, so we don't have to worry about writing the commands ourselves to manipulate the data. Alright, well cheers friends, and this wraps up this video, and I will see you in the next lecture.